Okay, illustrative math, unit 3, lesson 5 is called negative rational exponents. All right, so our goal is I can interpret exponents that are negative fractions, okay? So negative, obviously everybody knows what negative means. Rational basically just means fraction. So, if I give you something like 3 to the negative 1/3, okay, what is that going to equal without a calculator? That's what we're trying to do. A lot of kids just reach for their calculator here, but we're going to try to interpret it without one. All right, evaluate mentally. 9 squared, 9 times 9 is 81. 9 to the negative 2. So negative exponent flips it to the denominator, so it's 1 over 9 squared, which would be 1 over 81. 9 to the 1/2. So remember, the top number is power, bottom number is root. So it's 9 to the first under the square root, and I don't need to write the 2 in there. So square root of 9 is just 3. And then 9 to the negative 1/2. Well, I'm kind of going to use these two things put together. And I'm going to say, okay, well, 1 over 9 to the 1/2 gets rid of the negative. And then it's 9 to the first square root. So square root of 9 is 3. So it's going to be 1 over 3. So that's what we're doing today. Complete the table as much as you can without using a calculator. You should be able to fill in 3 spaces, okay? So let's see here. So we're taking 2 to a power, and I think I actually left part of that blank on accident. So let me flip to my book. Yeah, I'm supposed to have some numbers here. So this is filled in your book. I believe it's -2, -5/3, -4/3, -1, -2/3, -1/3, and 0. So I'm going to just basically rewrite all those with those exponents. So 2 to the -2, 2 to the -5/3. I'm just going to go through the whole thing. So the 3 I can do looks like this one. This is going to be 1 over 2 squared. I'll do a little scratch work over here. 1 over 2 squared is 1/4. This one here is 1 over 2 to the positive 1, 1/2. And then anything to the 0 is 1. So there's the first part. Plot these powers of 2 on the coordinate plane. Connect as smoothly as you can. Then use a graph to estimate the other ones. Okay. So plot these points here. So if x is -2, think of this column as y. So it's almost like this is my ordered pair, -2, 1/4 basically. So I go left to 1/4 is 0.25. That's right there. -1 is at 1/2. That's right there. And then 0 is up here at 1. So you can see it's not a straight line, because if I connect these, it's definitely not a straight line. So it's definitely curving. So I'm going to do my best here. It's kind of hard with this pen on here to do it. Oh, that was actually really good. All right, so let's do some estimating. So let's see here. When x is -5/3, I go right here. Find that point. Looks like 0.3. When x is -4/3, We'll call it, whoops, call it 0.35 maybe. And again, we're just estimating. We aren't positive on this. Negative 2/3. That one looks pretty good. That looks like 0.6. Negative 1/3. Pretty close to 0.8. Maybe a little under. I'm going to go with 0.79. So there we go. We got them estimated. So let's make sure we did everything here. Plot the powers of 2, connect, use a graph to estimate. Okay, good. Let's go on to our next thing. So let's investigate 2 to the negative third, or negative 1/3. Write 2 to the negative 1/3 using radical notation. So I'm going to get rid of the negative exponent. I'm going to write it as 1 over 2 to the positive 1/3. And I'm going to rewrite it in radical form. So it's 2 to the first and the cubed root. Okay. So I'll tell you what, I really don't need that 1 there. I wrote it just so you remember where it goes. And there we go. There's that right in radical notation. Let's go here. What is 2 to the negative 1/3 raised to the third power, cubed? So algebra 1 rule, power to a power, you multiply. You might remember, a to the m raised to the n is a to the m times n. That's from algebra 1. So if I multiply these, that's going to be 2 to the negative 1, which is really 1 over positive 2. Raise your estimate of 2 to the negative 1/3 to the third power. What should it be? So we know it should be 1/2 because we just did it here using exponent rules. So I got to go back. 2 to the negative 1/3 was right here, this one. So I got 0.79. So I'm going to take my 0.79 because what I said 0.79 was about 2 to the negative 1/3 from my graph. And we'll see how accurate it is because it should be equal to 1/2. So there it is. I'm going to get out my calculator and I'm going to type it in and let's see what happens. So I'm going to do 0.79 to the third. And I was pretty close. I got 0.493, which is pretty close to 1/2. Let's just see. I had originally thought it was 0.8. So if I take that to the third, that was a little bit more off than I ended up being. So we were pretty close. All right. So let's investigate 2 to the negative 2/3. So we're going to write it in radical notation. So it's going to be 1 over 2 to the positive 2/3, which is going to be 1 over, remember, power over root. 2 squared cubed root. So if you want to write it as 1 over, let's call it cubed root of 4, that would work, okay? So what is this here using exponent rules? So you multiply. So if I cube this, it's going to be 2 to the negative 2, which is 1 over 2 squared, which is 1/4. Now, just for the heck of it, just for fun, I'm going to cube this. If I cube a cube root, well, let's cube the 1 first. 1 cubed is 1. If I cube a cubed root, they undo each other. So that would be 1 over 4. So it's kind of the same thing up there too. So get rid of it. All right. So I'm going to go back. I'm going to go from my graph. I'm going to get my estimate. 2 to the negative 2/3. I'm going to take it to the third power. Here it is. 2 to the negative 2/3 was right here. So I got 0.6. let's say equals 0.6. So if I cube 0.6, let's get my calculator. I should get close to 1/4. 0.6 cubed is 0.216. So my graph might have been a little bit off, but I was still pretty close. Okay, 1/4 is 0.25. So we were close, but a little off. Little off. All right. So for each set of three numbers, cross out the expression that is not equal to the other two. So, okay, 8 to the 4/5. That's going to be power over root. So this one and that one, so we get rid of that. Let's do this. 8 to the negative 4/5 is 1 over 8 to the positive 4/5, which is 1 over 8 to the 4th, 5th root. Notice it did not make it negative, so that one is gone. Let's see here. Well, let's do this. 4 square root of 4 cubed, so that's going to be power over root, so that would get rid of that one. Let's do this one here. This is going to be 1 over 4 to the 3/2, and then if I want to move it up, it'd be 4 to the negative 3/2, so that would be this one, so that one's gone. All right, using radicals, so 17 to the 3rd power square root. Or you could do the other way. You could say the square root of 17 and then take the whole thing to the 3rd power. Those are going to give you the same number. 31 to the negative 3/2. So let's do it 1 over 31 to the positive 3/2. And then let's get it in radical form. So 31 3rd power square root. So it's 1 over. So only exponents. So the root here, if it's not written, is 2. So it'd be 3 to the 4th power over 2, which would be 3 squared. It says using only exponents. So you could leave it as that, or you could, it's easy enough to make it 9. If I go here, this last one for 3b, 1 over 5 to the 6th power over the 3rd root, cubed root, 1 over 5 squared, that would be fine. Or you could just make it 1 over 25. Okay. But the key is be able to do this without a calculator. Okay. All right. Match each expressions into groups according to whether they are equal. Be prepared to explain your reasoning. Okay. I would write them all with fraction exponents because then you can compare apples to apples. So let's write this as 3 to the 4 over 2, which would be 3 squared. This would be 3 to the 2nd power over 2nd root. Remember, power over root, which is 3 to the 1st. Multiply these powers. 1/2 times 4 is 2. So this one, I might have to do a little scratch work over here. This is going to be 2 over 2 is 1. 3 to the 1. So then you add your powers and we get 3 squared. 3 times 3 is 3 squared. Multiply here. 2 times 1/2 is 3 to the 1st. This one's already done. 3 to the 4/2, we'll just reduce your fraction. That's 3 squared. And then this one, multiply your powers. This is 3 to the 1st. So basically, I got 3 different numbers. I only got 2 different numbers. I got 3 to the 1st and 3 squared. So I'll just group them here with color to make it easier. So all my 3 squareds are right here, 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 and here. And then my 3 to the 1st is here, here, here. Okay? So how are 2 to the negative 1/2 and 2 to the 1/2 alike? How are they different? Well, 2 to the negative 1/2 is 1 over 2 to the 1/2, which is 1 over the square root of 2. 2 to the 1/2 is just the square root of 2. So like I would say both have square root of 2, but the negative 1 is going to be much smaller because it's 1 over. So let's say here 2 to the 1/2 and 2 to the negative 1/2 are flipped. How could you write 5 to the negative 2/3 with radicals? I'll come down here. I'm going to write it as 1 over 5 to the positive 2/3. That gets rid of the negative power. And then remember, top number is your power, bottom number is your root. So I'm going to write it 1 over 5 squared cubed root. Okay, if you wanted to make that 25, those would be equivalent either way. Okay, so I'll just... And then what would be the result of cubing this? So if I take this and cube it, power to a power, you multiply. So remember when you did fractions, negative 2/3. I don't really need a calculator here. These cancel, so it's negative 2 times 1. So it's 5 to the negative 2, which is 1 over 5 to the positive 2, which would be 1 over 25. Kind of cool how I did that without even touching a calculator. All right, so did a lot there. I can interpret exponents that are negative fractions. I would say we're pretty good at that. So cool down, write 7 to the negative 2/3 without exponents. So I'll come over here for 1. So 1 over 7 to the positive 2/3 gets rid of the negative. And then I need 1 over 7 squared cubed root. Or I guess we could say 1 over cubed root of 49. Okay, either one of these are fine. And then without radicals, this one here is going to be 11 to the 5th power over the 4th root. And then if you can reduce the fraction, do it. 5/4 does not reduce, so there it is. Okay. All right. So I hope you enjoyed this lesson, and thank you for watching.